Okay, so welcome to part 3 of our week 5 material. In this section, we're going to take a look at facilities for doing string handling, that is, various functions that we can call that manipulate stir values. We already know several things we can do with strings. For example, we know that the plus symbol between two stirs is concatenation. So what I'm saying here is hi as a stir plus space world as a stir, and that produces high space world. So S now contains the single string high space world. We know that the asterisk, the times operator, is repetition. So S2, since I've said S2 gets S times 4, is high world, high world, high world, high world. Okay, we can index within a stir. A stir is a sequence, therefore we can index within it, and we can also slice it. S sub 3 is the W right here. And S sub up to but not including 2 is just characters sub 0 and 1, which is the substring high. We can split a string into a list of substrings. Here I'm doing the most common thing, which is to split the string at space characters. So M now contains, yes, sorry. I got myself confused for a moment that I was splitting S2, so I was wondering where all this other text was. But no, we're splitting S at space, and so that results in a list of two strings, the string high and the string world. There are a bundle of other kinds of manipulations you can do with strings, and this website location here shows the methods that are available for interacting with strings in Python 3.7. So you can take a look at that and experiment with the methods. We're going to go through several of the most commonly used ones in the rest of this section. So let's suppose that I have a string S. This is a test. If I say s.capitalize, what that does is to turn the first character in the string into an uppercase letter. Or I should say, in this case, what it's doing is it's retrieving the value of S, and it's returning or yielding a stir in which the first character is capitalized. This does not actually change S. All right, so it fetches a copy of S, modifies that copy of S, and in this case, that modified copy is displayed on the screen, but S itself is not changed. If I wanted to save that modified string, I could say S gets S.capitalize, and that would save the copy. I don't actually want to do that. Let me say S2 gets S.capitalize so that you can see that S is unchanged, S2 is the capitalized version. This next one, S.title, I'm not sure in real life how often this is used, but what it does is to take a copy of S and to return S with the first character in each word made uppercase. So you can think of that as being like the title for a chapter or a book or an email or something. S.upper converts all lowercase letters to uppercase. Now, anything that's not a lowercase letter is unaffected, so the spaces are unaffected by this. And if I had something like this is 123 exclamation mark, and I converted that to uppercase. All right, now in the previous examples, we were using a variable S, and we were invoking these methods on S. But S is just referring to a stir, so I can go ahead and do these methods directly on a stir literal. if I say this is a test 123 exclamation mark dot upper, as you can see, the lowercase letters are converted to uppercase, but all the other characters within the string are unaffected. We also have the dot lower method that does the opposite thing. So if I have some string that has a mixture of upper and lowercase characters in it, and perhaps non-letters also, then the uppercase letters are converted to lowercase. Anything else is unaffected. So there I have another test, 1, 2, 3, 4, exclamation mark 3 times. So those are methods, capitalized, title, upper, and lower, that alter the letter case of certain letters in the string. Next, we're going to take a look at some methods that modify the justification of a string within a field of a certain width. I'm going to set S to refer to word, the 4 characters W-O-R-D. And if I say S2 gets S dot center 10, 10 is going to be the field width in which I want S, that is word, to be centered. By default, space characters will be positioned in front of and after the value of S in order to fill that out to a total of 10 characters in length. So when I look at S2, what I see is that S2 is now a string containing 1, 2, 3 characters, 1, 2, 3 spaces, excuse me, followed by word, followed by 3 more spaces. And I can confirm, as opposed to highlighting on my screen, I can confirm that S2 is 10 characters wide by requesting its length. All right. As a second option, argument, I knew I could think of the word eventually, as a second argument to center S.center 10, so we're going to have 10 characters wide, and as a second argument we can specify some string that we would like to use to fill in before and after the word that we're centering. So by default we get spaces, but here I'm asking to have dash characters or hyphen characters used. And we see that we have 3 dash characters, and then word, and then 3 more dash characters. Once again, the overall length of that string is the 10 character width that I asked for. In addition to centering, I can ask for left justified or right justified positioning of my string. So S is still just plain word, and if I say S.ljust 10, that means to do a left justification in a field 10 characters wide. So what I get out is word with 6 spaces following word, and it won't shock you to know that you can add an additional argument, which is a fill character. In this case, it's a 1 character string, a dot rather than a dash. You can use any fill character you want. Here I'm right justifying the string word in a field 10 characters wide, and there are going to be 6 dot characters filled in on the left of word. Okay, now there really is no limit at all to what you can use for your fill character, so I could put in a star here, or I could put in, let's do an ljust. You can put in a letter. Okay, so you have a lot of flexibility there. Getting rid of characters that you don't want, specifically spaces, or generally speaking, white space characters that you don't want, is called stripping. So let me modify S to, well, let's see, S contains word. Let me modify S to be S.centered in a field 10 characters wide. So S now contains space, 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 word, space, space, space. And if I say S.strip, then by default, that is going to strip off both the leading and the trailing so-called white space characters. White space characters include not only spaces, but also things like tabs and new lines and carriage returns and form feeds and some other things we haven't talked about. So S.strip yields just the 4 characters word. I do want to point out here, let me create a S2 gets, this is a test. In fact, let me add some more spaces in here. Let me put some spaces at the beginning as well. That stripping only eliminates leading and trailing white space. It's not going to strip out any of the white space in the middle, and it's not going to compress these 4 spaces here to just a single space. Okay, so all the strip does is to eliminate the leading space and the trailing space. Any other spaces in here are unaffected. Okay, so here is S with both leading and trailing spaces around word. If I say S.lstrip, that only eliminates the left side white space. So I still have the right side. And of course, rstrip does the opposite thing. It eliminates the right side white space and leaves the left side unaffected. Let me create another variable here in which we're going to have a horizontal tab and then a test and then a new line character. Tabs and new lines are considered to be white space. So when I strip this line, the horizontal tab at the beginning and the new line character at the end are eliminated. So you might be tempted to use something like rstrip to eliminate the new line character at the end of the line. And for this particular test case, where I've got horizontal tab, a space, test, and then new line, that works fine. So rstrip gets rid of that new line. But sometimes your text, let me say line 2, will have, let's see, how doth the little crocodile improve his shining tail? Here is a line from a silly poem, and this line, as we've read it in from this from some text file, has a new line at the end. It also has 3 spaces prior to that new line, and it could be that doing an rstrip of line 2 is really not what you want in this case. If you only want to get rid of that new line character, but you do not want to get rid of those 3 space characters, then recall our slicing trick. If I say line 2 sub colon -1, that means to strip, well, technically it actually means to return to me a slice which includes all of the characters in line 2 up to, but not including, the very last character. So that is a safer way in general of only eliminating the new line from the end of a line without getting rid of any other white space that might be at the end of a line. That additional space there, especially if you're dealing with columnar data in which the positioning of the characters is important. Maybe you're dealing with a file where every line in the file has 80 characters worth of information, and maybe the space character is meaningful in certain positions in the line, then you want to only get rid of the new line character at the end. You don't want to accidentally also eliminate any spaces that might be at the ends of those lines. Okay, so that's the business of stripping. Either both ends, or just the left side, or the right side. There are also a variety of methods available for testing attributes of strings. Here I'm creating S to refer to, and now I don't know why, I don't know what my thing is about wanting to use examples that are hard for me to type. But here I'm having S refer to fantabulous for some reason. And if I ask whether S is lower, the is lower method checks whether all of the characters, checks whether all of the letters in the string are lowercase. And if they are, this is going to be true. On the other hand, is upper tests whether all of the letters are uppercase, and of course this is false. Another test I can perform is alpha, which is testing whether all of the characters in the string are alphabetic. And that's true. Another test is alnum, which is a test for alphanumeric characters. So if I have S gets howdy 1, 2, 3, 4, and I ask whether this is alnum. Interesting. Now, notice that I get false because the space here is not a numeric character. So let me instead set S to howdy 1, 2, 3, 4 without the space. And I get true. Okay? Another thing you can do, which may be an uncommon thing for you to want to do, is to test whether a certain string is a valid Python identifier. That is, it's a valid string that could be used as a variable name or function name or class name within a Python program. And so here, root 66, whoops, forgot my quotes, root 66. This, of course, is a valid Python identifier because the first character is a letter or an underscore, and all of the following characters are either letters or underscores or digits between 0 and 9. So is identifier for root 66 is true. 23 skidoo, on the other hand, if I ask whether this is an identifier, then it's false. Okay, now here's a piece of worthless knowledge, utterly worthless knowledge. 23 skidoo was, about a century ago in the United States, a very popular slang term that meant, let's get out of this place. So who knows why, but it's not a word that I made up. It is actually an historical word popular in the United States, but not recently. Okay, now if I ask whether some str is numeric, then if all of the characters in the string are numeric characters, that's true. This test is a little bit misleading because if I say 12.34 is numeric, I get false. Now clearly 12.34 is a valid float number in Python, but the is numeric test is actually just looking at each character to see is that character a digit between 0 and 9 or not? Okay. I can test whether something is in the form of a title, which is checking whether the beginning of each word is an uppercase letter. I can also test whether all of the characters in some string are whitespace characters. So space, horizontal tab, new line, carriage return, form feed, which pretty much nobody uses nowadays, but that used to be important back in the days when people had paper printers and you could display, you could send a form feed to the printer to spit the page out. All of these things are whitespace characters, but something like A, of course, is not. Okay, so those are several examples of methods that you can use to test the characteristics of strings. Now, we've talked about splitting a string. If I have s gets, this is a test, and I say m gets s dot split at spaces, m is now a list of 4 strs. The inverse of split is join. And this is confusing when you first try it, because you have just split s into a list of strs, and so you might think, well, now I should just be able to say m.join space to get those strs joined back together with spaces in between. But join is not a method of the list class or the list data type. Join is a method of the string, the str type. So what you do, which seems quite strange, is you say space dot join m. All right, so in other words, notice when I hit the parenthesis character here, in my shell is displaying a little bit of documentation. This thing is called the docstr, the docstring, for the join method, telling me that I can give an iterable here, and m is the list of strs, the list of substrings that I split s into. So I give that iterable as an argument to the join function. And what happens is this space has all these strings joined around copies of the space. And so that's how I get back my original string. Okay, so remember that join is a method of the string class. It's not a method of the list class. You can use any join string that you want. So s is, this is a test. M is a list of the substrings of s. But if I wanted to join those things back together with some other characters in between, I can just give any string that I want to join those strings around. So if I say plus 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 dot join m, then I get, this is a test with 3 plus symbols between each of those substrings. This is a test. I can count how many times a string occurs within some other string using the count method. S still contains this is a test. If I say s.count the substring t, well, there's 3 of those. I've got this is a test, and so I get 3. If I say count is, I get 2. All right, so I've got is here, I've got is here, so there are 2 occurrences of is. Notice that count is not counting words. it's counting the number of occurrences of some substring inside of S. I could say s.count space, which will tell me there are 3 spaces. I could say s.count s space I, and I get told there's only one occurrence of s space I in this is a test. We can index within a string, so I can say s sub 9, and that turns out to be, let's see, sub 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So s sub 9 is that third space within S. If I know a subscript, I can use the subscript to access the substring that I want. If I don't know the index, then I can use the find method to discover the index of a certain substring. All right, so here's S as a reminder, and if I say s.find t, the substring t, well, the first occurrence of that substring little t starts right at the beginning of the string. So the index of little t there is 0. I only get back the let me phrase this carefully. I only get back the next occurrence of the substring, not the indexes of all of the occurrences of the substring. As an additional argument to find, I can specify a beginning index to start from, and then from there continue searching to the right within the string. So since I have discovered that there is a little t at position 0, let me in my next find method say, all right, got it, I know there's 1 at position 0. Let's start from index sub 1, and let's see what the next index of the little t is starting from position sub 1. And it turns out that the next t is at position sub 10. All right, which makes sense. You may recall that this space was at position sub 9. All right, so we've got a t at position sub 0, and then sub 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have 10. So the next t is at position sub 10. And I can continue in this way by saying, all right, cool. I've got a t at position 0. I've got a t at position 10. Let's see if I have any t's starting at position 11. And I do. I have one at position sub 13. Cool. Let's see if I have any t's starting at position 14. Now, 14 is actually beyond the end of the string. So clearly there cannot be any more t's beyond the end of the string. If the find method is unable to find the substring that you're searching for, it will return to you a -1. So -1 is the find method's way of saying, sorry, I can't find that. And it doesn't just occur when you're beyond the end of the string. If I were to say, okay, here's what S contains. This is a test. If I were to say s.find xyz, that string does not exist within S, and so I get back -1. All right, so you specify the string that you want to look for. Optionally, you can specify the starting subscript that you want to start looking for that string. If that string is not found, then you get back a -1. All right? Now, you can do a search in reverse as well. So here's S, just as a reminder. And if I say s.rfind a little t, that does a search in reverse. And I get back the 13 because, as we've seen, position sub 13 is the last t. If I say s.r find t starting from position, and in this case we're working backward, we're working in reverse. Look for a t starting from position 12. I get, oh, okay, this is, it's still looking forward. Okay, that's interesting. S.r find t. Okay, so what I had forgotten is that rfind basically uses the same notation as slice notation. And so if I say s.rfind, notice the little help message that I'm getting here. I specify the substring as the first argument. Then I specify start and end as additional arguments. The start and the end always have to be in ascending sequence. So what I want to do, since I have found a t at position 13, is to specify 13 as my end, which is going to be one too far. So I'm going to say t starting from position sub 0 and going up to but not including position 13. This is going to do a reverse find and tell me that the second to last t is at position 10. Then if I do an r find starting from position 0 and going up to but not including 10, I find the t at 0. This is a little awkward, but that's what's going on when you look for things in reverse. All right. Here's S. If we do a find for capital A, of course there is no capital A. I can also do a find for a multi-character substring. So if I do a search for is, the first occurrence starts at position sub 2, and the next occurrence, looking from position sub 3, is at position sub 5. Okay, so that's an illustration of finding substrings within strings. By default going forward, but you can also go in reverse by using rfind instead of find. You can replace a certain substring with some other string by using the replace method. Here's S. Once again, this is a test. If I say s.replace little t with capital T, this replacement is going to occur throughout S. Now, S itself is not going to be modified. Once again, this behaves like other, like the justification and upper and lower methods that we've looked at. We start with a copy of S, and within that copy we replace little t with capital T. And that happens for each little t. So each of the little t's is replaced with capital T. S is unaffected, but the replace returned to me a copy of S with the replacement performed. You can also specify how many replacements you want as an additional argument. Notice in this help message here it says count. So I can say, to specify a count, as the third argument, and this time only the very first occurrence of little t gets changed to capital T. The replace function can also be used as a way of removing characters by replacing some string with an empty string. All right, so if I say replace little t with an empty string, I've just got two single quotes next to each other here. Now I have his is S. All right, all three of the t's have been replaced with nothing in this case. And I'm not limited to single characters. I can say replace some multi-character string with some other multi-character string. In this case, IS has been replaced with capital ABC in the two places where little is occurred. Okay, so this gives us quite a range of flexibility. We can start with a string. We can convert that string into uppercase, lowercase, some combination. We can format that string to be centered in a field or left or right justified in a field. We can test the string's attributes. We can search for substrings within the string. We can count how many times a certain string occurs. We can also locate substrings within the string, and we can replace substrings within the string. So we have a considerable amount of capability for working with strings. All right, and this Lab 5.3 will give us some practice with these string handling methods.